All right, thank you. So this is joint work with my colleague, Elio Serra, and it's work in progress. So I'm going to show you a lot of pictures. And I think the topic, the title, is pretty self-explanatory. So there are many examples of turf wars out there. I'm not going to describe each of them in detail, but some of the more popular ones. Where I'm from, in New York City, there's been a long-standing issue about who gets control of emergencies. So is it the fire department or the police department that should have primary responsibility? This actually became an issue during 9/11 when it was argued that the inability of these two agencies to coordinate or to work together probably hampered rescue efforts on that day. This issue, in fact, was recently resolved in 2006. The New York Police Department is, in fact, in control. But for decades before that, this was a problem. The U.S. military branches, many of you know, the U.S. Navy has an Air Force. The United States Marine Corps has an Air Force. The U.S. Air Force has an Air Force. Okay? And these different units often don't work very well together. Okay? The 9/11 Commission report also pointed out that the United States has 17 different intelligence agencies, and many of these agencies often have trouble coordinating their efforts as well. Maybe one example I will just say a little bit about is the Drug Enforcement Agency in the U.S. There's a famous book written in 1978 by James Q. Wilson called The Investigators that talks about how the Drug Enforcement Agency during that era worked. The agency was organized along regional lines. Okay, so Detroit had a region, Chicago had a region, Houston had a region, and it would give incentives for performance to each of these different regions by allocating more resources to those regional directors who performed well. So this was called buy money. And so the problem was this. The folks in Washington wanted to take down kingpins, right? The big guys. The problem was that the big guys often operated across these different jurisdictions, okay? And so you may need to have the people in Houston coordinate with the people in Chicago in order to get something done. So what was the problem? When it came down to whether or how to allocate their effort, these regional directors were often very hesitant to share information or to collaborate with people in the other regions because they were worried that their rivals in the other regions would receive credit for any investigative successes. And as a result, or so the book argues, all sorts of effort was diverted towards going after small-time dealers as opposed to kingpins. Okay? Just a few other examples that are maybe more contemporary. There's been a lot of discussion about how to reorganize medical care under the U.S. Medicare program. And then there, of course, has to be a financial crisis example. So the CFTC and the SEC in the U.S. have for decades haggled over who gets to regulate derivatives. Okay, so these are just very common examples of turf battles that you could uncover with a quick Google search. One thing I will note right now, and this is just a very kind of casual piece of empirical work, right? Public sector examples are much more common for some reason. Okay, and so maybe after we talk about this for a minute, I'll be able to come back to that. Yep. Well, I'm sure that's part of it too, but yeah. Okay, so this is the problem, right? We are concerned about the performance of all sorts of organizations, and yet we see that these organizations are often engaging in what we colloquially refer to as turf battles. And so what we want to do was to kind of ask this question, well, what's a turf war? Okay? And as best as we could piece things together, we kind of came up with this. Okay? This has to do with jurisdiction-minded behavior. So it's very common for us to assume that bureaucrats are maybe interested in policy outcomes, they're interested in budgets. Here they're going to care, they're going to be induced to care about having jurisdictions over problems. Okay? The other feature that often comes up is that there are often inefficiencies that are identified with a turf war. So maybe there's a failure to share information, or maybe key actors are denied resources that they might need to apply to a problem. So what we want to do then with this model, or what we hope to do with this model, is to answer a few questions. Right? When do turf wars occur? How can they be prevented? And one thing we won't do is this. Okay? We won't, I mean, in many ways, the simplistic answer to how do you get two people to stop fighting one another is to combine them into one unit. Okay, so if you're concerned that these two different air forces are fighting their own separate campaigns, maybe one answer is just to have one air force. Okay, so we won't consider that because, first of all, I think in practice it's very difficult to just combine organizations, and even when it is possible, intra-organizational battles, intra-organizational turf wars can often be just as bad as turf battles between organizations. Okay, so we're going to be focusing on this problem of getting two different units to try to collaborate. All right, so I want to be fair to the literature, but this is really about what I come up with. Right? There really isn't a lot written on turf wars per se. Okay, there's a lot of related ideas though. Okay, and maybe I can group these into three different families. Okay, there are a lot of contracting models that deal with multi-agent problems. Okay, and so the closest kind of model might be these models of rank order tournaments. Okay, there are models that focus more on this question of when agents will share information. I think this is quite relevant too, although it's not clear that information is necessarily a part of a turf battle, at least the way we're gonna talk about it. Okay. Finally, there are a whole bunch of other models that kind of talk about other kinds of ways in which different agents might come to collaborate or compete with one another. Okay. All these are great. None of them quite get specifically at, I think, what we want to get at. Okay, so what do we do then? Okay, the first thing is this. Okay, we want to maybe try to define what a turf war is. Okay, and to us, there are basically three features that are central. Okay, so the first is joint production. Okay, so we have a collection of agents, and there is at least the potential for these agents to somehow combine their efforts so that their aggregate output is better than the output of any single agent. Okay? The second is that there's some notion of competition. Okay? So one of these agents will receive some benefit from winning or somehow performing better than the other guys in the population. And finally, maybe this is the key one, there's some notion of property rights. Okay? I mean, some agent will have primary jurisdiction, and because of that, she will be able to determine whether other agents get to participate in solving the problem or not. Okay? So these are just sort of three ideas that seem to run or seem to be common to every example of a turf war that we've seen. And so what we want to do is to come up with a fairly minimal model that incorporates these three different features. Okay, so I'm going to describe a very basic model, and then I'm going to show you some pictures that are going to be actually from an even simpler version of this. Okay, but this is at least the basic thing that we've worked on. Okay, so think about an environment where we have two agents. We'll call them A1 and A2. Okay, there's going to be a task, and one or more of these agents will have jurisdiction over the task. In other words, that agent, an agent with jurisdiction, will be able to make some sort of a contribution that will translate into an outcome along that task. Okay? So when an agent has jurisdiction, AI is going to generate an output, xi, okay, between 0 and theta. Okay? And there's going to be an exogenous prize for achieving the highest output in this world. So whichever guy, if both guys have jurisdiction, the guy with the highest xi, all right, wins the prize beta. Okay, so we can think about this as maybe something like a career concerns model, right? Or maybe we're both competing for a promotion, or the fact that my agency does better than yours means that all sorts of other budgetary rewards off in the future will come my way. Okay. Utility in this model, very simple. Okay? Each agent will be motivated by the outcomes that are produced. Okay? So in the first line there, if both agents have jurisdiction, then agent I receives mi times the sum of the outputs. Okay? And of course you get the reward if you beat the other guy. Okay? If only you have jurisdiction, okay, then of course you only get the utility associated with the output that you generate, and you automatically win the reward beta. Okay? And if you don't have jurisdiction, well, you still care about the outputs, but that output is being generated by the other guy.
Can I ask a question?
Yes?
Why is this assumption? I mean, if it's about the safety of New York, if I am the other agency and the jurisdiction given to police, I still benefit from their output. No?
Yes, but you're not. You care about your contribution to it, right?
I thought the beta was the price of.
No, the beta is, if you're the guy who's given credit for saving the burning building, then maybe there's a promotion in this for you or something like that. Okay.
So
yep.
The beta, I was thinking of it as a reward, but here you get it no matter what XI you exert.
Yes. For now, yes.
Oh, okay.
Yeah.
You're gonna, at some point you'll have the cutoff level.
Yeah. So we're just going to start here, but we can push this a little bit further, right? Which is that in a world where we think that there are contracts, then this beta is something that we're just designing, right? And we're making this a function of beta of X. And right now we're just going to start with this. Okay. All right. So let's talk a little bit about effort and how they translate into outputs in this world. Okay. So we're going to start with this. Okay. If AI has jurisdiction, then the output will be determined in the following way. So initially, we're going to treat the two agents as being asymmetric. Okay? Agent 1, okay, will simply produce their productivity level, okay, which is going to be a uniform draw between 0 and theta. Okay? Agent 2 has to work. Okay? So if you don't work, so work is a binary decision here. If you don't work, you produce 0. Okay? And if you do work, then you produce this draw from between 0 and theta. Okay? We're going to treat these theta parameters as private information. Okay? And so the idea will be the following. We'll think of A1, we'll call A1 the originator. We'll think of A1 as the person who has original jurisdiction. So this is the guy who can choose whether she wants to keep the jurisdiction for herself or to share it with A2. And so the idea is that, well, maybe A1 has already sunk some sort of investment into this project. Okay? And so I've sort of decided already whether I'm going to be working on this. And now I'm just going to decide whether to share with you. Okay? And A2, on the other hand, hasn't made this effort investment, and so we'll have to decide, conditional on being shared jurisdiction, whether to work or not. Okay? And this effort will be costly. Okay, so the basic model, real simple. Okay? First, we'll just have nature draw everyone's types. A1 will decide whether to extend jurisdiction to A2, okay? Or you can think about this in the reverse too, right? It could be that both agents have jurisdiction. A1 is in a position of doing something to cut A2 off from further participation, okay? And if given jurisdiction, our A2 gets to choose whether to exert effort and participate or not. Okay, so we can think of A2 not working as being equivalent to refusing this shared jurisdiction. Okay, very standard perfect Bayesian equilibrium. There is an out of equilibrium information set. It doesn't really matter. Okay, so what I want to do now is to explain a little bit of intuition. I'll sort of come back to this kind of figure several times. And the way I'm going to do this is to ignore hidden information part. Okay, so we'll just assume that everyone knows what everyone else's thetas are. Okay, and this will actually get us most of the way there. So the first thing I want to do then is to think about this world where, again, theta 1 is known. Okay, well, theta 2 is known too. And if A1 shares, what are A2's incentives? Okay, so on the horizontal axis, we have theta 1. So again, this is agent 1's productivity. On the vertical axis, we have agent 2's productivity, theta 2. Okay? And so as your intuition might tell you, if your theta 2 is very high, well, then you're going to be very motivated to work. Right? In fact, if it's really, really high, then you actually don't care about whether you win or lose. Okay? Under some circumstances, you're perfectly willing to work, even if you know you're not going to get beta. For lower values of theta 2, well, then the fact that you're going to win is going to matter. Okay, so this will be the lighter gray portion here, what I label victory motivation. Okay, So really motivated types will work regardless. Other people need to be motivated by the possibility of winning. Yes?
Agent 2 doesn't see theta 1, right?
No, this is complete information. No.
Oh, I'm sorry.
Yeah, this is just to keep everything real simple. Okay. Okay. So if we were just to work out the algebra for this version of the game, okay. So again, knowing this, okay, what does A1 do? Okay. Well, it's easy to show that agent 1 is only going to share if theta 1, her productivity, is high enough. Okay? If your productivity is low, then you're thinking, well, agent 2 is going to be likely to work when they are a very strong competitor. I'm going to lose beta for sure, and so of course I'm not going to share. But if you're reasonably confident of winning, then of course you're willing to share. And this is actually the intuition that's going to come out of the incomplete information model as well. Okay? High type share, high type originator share, high type partners will work. And in some ways, this is the worst thing. If you think about the role of a principal or a social planner, this is actually what you don't want to have happen, right? I mean, you actually kind of want the lower types to share or the lower types to be working and collaborating. But instead, we have only guys collaborating in this northeast corner. Okay? So let me just say then what happens in the incomplete information model. Okay? So we're going to think about an interval equilibrium, okay, where sort of all types within a neighborhood in a certain neighborhood of theta will sort of do the same thing. Okay? Yes?
Just to understand welfare, so what does it mean welfare here? Because these are these rents of these guys, so you just sum these rents.
Mm-hmm.
There's no, the output doesn't,
So there's no, so one thing we might want to think about here is if you were, let's say you were a citizen or you were the politician overseeing these two agents. I mean, what would you want? You have this productive capacity. You want it to be used. You would want, you would basically want both of these guys to be contributing. Okay? So in the model that we have here, agent 1 is always contributing. Okay? And so the question is, well, when do we realize the productive capacity of both of these agents? Okay? And really what happens is we only get it in this very small set of parameter values up in the northeast. Or it might, yeah.
Maybe.
Yes?
I was confused over about the welfare plan. The production function is just linear, right?
Yeah.
And the incremental cost not a function of the theta. So I think the social planner cares most about getting effort when the thetas are high. Like the social benefit of effort is highest when the theta is high.
Oh, sure. I mean, this isn't social welfare in the sense that we're accounting for all costs. This is just, we're kind of asking, right, when can we get people to work together? Okay, and we can imagine that this planner might have different weights on what bureaucrats do with their time, right? I mean, because the K might represent other things that we don't care about, right? This could be agency slack or whatever. Okay, but I'm using collaboration, in other words, sharing and effort by the potential partner as being, in some ways, the normative standard here. Okay, so let's go back to the incomplete information version of the game. Okay, and this is all very, I think, simple and standard. Okay, we're going to think about an interval equilibrium. Okay, so suppose that A1 shares for a range of values of theta 1. Okay, between theta underline and theta overline. Okay, then it's very easy to write down the expression for when our partner will be willing to work, right? You work if that expected payoff is better than that of simply letting this go and not exerting any effort in investing in your own productivity. The only extra term up in that expression is this omega. That's the probability that A2 wins beta. Okay, and that's easily calculated because we've assumed nice uniform distributions. Okay, and so what this means is that for any interval of sharing originator types, okay, there's going to be unique theta 2 type, I call it tilde theta 2, such that higher productivity types will work, lower productivity types will shirk. Okay, and so we've just kind of graphed it here. Okay, and so this will be increasing in the worst type of theta 1 that shares, right? And this makes sense, right? Because if the set of sharers becomes smaller and smaller and more competitive, then of course the response by agent 2, okay, will be to become more and more hesitant about working, because this means that, all right, the competition conditional upon sharing will be really tough. Okay, so then, almost finished. Given this tilde theta 2, right, the probability that A2 will work, okay, is very easy to calculate. Okay, given that probability, okay, we can calculate the probability that A2 wins conditional upon working. Okay, and this allows us to write down the condition for whether our originator will share. And this actually reduces down pretty nicely. And so what we get is this. So let me just give some intuition here. Okay, A1's payoff from sharing, okay, or relative payoff from sharing, is increasing in type. Okay, in other words, utility from sharing minus utility from autarky, or not sharing, is continuous and increasing in theta 1. Okay? Higher types are always going to be more inclined to share, so that means the upper bound, theta overline, is always going to be capital theta. Okay? And so, again, we have the highest types of theta 1 always sharing. Okay? The problem then is then for us to find the lower bound on the set of types that will share. Okay? It's very often the case that we're going to hit corners. Okay? And so what that means is that we'll often be in a world where there will be either no sharing or full sharing. Okay? And when there is an interior solution, we can write that down too. Okay, so the last 3 slides basically boil down to this. Okay? So as with the complete information case, okay, we have basically the high types sharing, low types not sharing, and then conditional upon sharing, right, the high types working, and then the low types not working. Okay, so we can report several sets of results, and I have to say that this is the part where we really just haven't, we really haven't done enough. Okay, so one thing is we can ask, you know, when does sharing happen? In other words, where is this theta 1 star? Okay, so you know, there's a lot here. I think I probably will skip part of the slide, but you know, some of the intuition is pretty clear, right? When beta is very high, okay, in other words, when the value of the reward is high, but M2 is low, well then you're not very inclined to share. Okay. The key thing to know here, I mean, I think I'm going to have a picture which I think will summarize all this stuff. The key thing to note is that, you know, it's relatively easy to get results on sharing, but sharing in some sense isn't enough, right? We're more interested in this combination of sharing and working, or what I call collaboration. Okay, but first let's talk about sharing. So here's some of the promised pictures. Okay, so we can read the figure as follows. Okay, the parameters in these two are identical, with the exception that on the right we have a higher M1. Okay, so we have a more policy motivated guy on the right. The horizontal axis is beta. Okay, and the axis that goes into the graph, okay, will be M2. So that's the amount, that's the extent to which our partner cares about policy outcomes. Okay, so one thing that you can see here, okay, is, okay, and the the vertical axis then will be the probability of probability sharing. So as beta increases, okay, then clearly the inclination to share goes down. Okay, as M1 increases, right, the more you care about outcomes, well, the inclination to share will go up. Okay, and higher values of M2, okay, usually, but not necessarily always, will correspond to more sharing as well. Okay, but again, this in some ways isn't the important thing, right? Because you can have sharing, and yet if this isn't reciprocated by working on the other side, then then the outcome is really no better than A1 not sharing at all. Okay. So what we can do then, and this, again, this is where we just haven't really gotten enough in terms of analytical results yet. Okay. We've taken the parameters of what was on the right side on the previous page, okay, and done the following. On the left, we see the probability that agent 2, our partner, now works, okay, conditional upon sharing. Okay, so the horizontal axis again is beta. The vertical axis, or the axis that goes into the figure will be M2, okay, and the vertical axis is the probability of working, okay. And so you can see here, well, it looks like some combination of high M2, okay, but moderate beta seems to do the trick, okay. In other words, higher beta is always sort of weakly bad for sharing, okay, but having some beta as an incentive to work is also important as well. And then finally on the right, we multiply these two, right? So we have the probability of sharing now and the probability of working. So on the right, we have really the kind of key figure, right? This is the probability of collaboration, okay? And one fairly, well, there are a few exceptions, but one fairly unambiguous thing here is that, right, higher values of M2 seem to encourage both more work and collaboration. Okay, so the key question then is, well, how do we get collaboration? Okay, and one quick answer that we can give is that, well, unless the cost of effort is 0 for our agent 2, okay, you will never sort of get this with probability 1. Okay, often instead what we observe is the sort of trade-off between sharing and working, right? And it makes sense because you're often most hesitant to share precisely because you think the other person is going to work and possibly beat you. What the figures suggest, okay, is that, right, a high motivation by the partner, in other words, a high M2 and a moderate value of beta, right, seem to do the trick. So that's kind of what we're trying to characterize. Okay, and also I think the role of beta is non-monotonic. Okay, in other words, high values of beta obviously inhibit sharing, but moderate values of beta are required in order to give people incentives to perform. Okay, so there are other questions here which I think are worth working on. The first is, we're trying to generalize the distributions of theta that we're working with, and so we think that the basic logic here sort of works under all sorts of distributional assumptions, so it's obviously much more difficult to characterize. Okay, and the second thing gets a little bit to John's comment earlier, which is where does this beta come from? In other words, if we could imagine how a contract would be written to assign a reward, what would that look like? And I think this might kind of come back to that point I made in the original 2 slides about where we tend to observe turf battles happening. Okay, and the conjecture is this. Okay, it might be the case that we so often observe turf battles in the public sector precisely because these are environments where the contractual instruments are really crude. Okay, so in other words, if all we're doing is battling over a promotion, that might correspond to this exogenous beta, right? But in an environment where we think that a principal is able to do strategically a rank order tournament, then perhaps they could perform quite a lot better than what we see here. Okay, so one thing that we can do, one thing we'd like to be able to do once our results are on more solid footing is this. Okay. It's possible that we can use this to suggest a few remedies for turf wars, okay? And so we can imagine how each of these different parameters might correspond to features that a designer might try to manipulate, okay? I've talked already about the reward, how we want these to be moderate. We can think a little bit about what these policy motivations, or MI, correspond to, okay? One thing that we can do is to think about situations under which we can ask, well, who do you want to have primary jurisdiction over a task? Who do you want to be the originator? Okay? It may be the case that we can draw an analogy between MI and what in government agencies we call the distinction between political appointees versus career civil servants. I mean, these are people certainly with different kinds of motivations for outcomes. Okay? And of course, the parameters theta and K2 might also correspond to other parameters of interest. What I want to do now, though, is to talk a little bit about extensions. It's funny to talk about extensions when the core model isn't even completely complete yet, but bear with me. Okay. So the first thing I want to do is this. How much time, maybe?
About 8 minutes.
Okay. Okay. So we'll do this real quickly. Okay.
10 minutes.
Okay. So the first thing we can do is to try to make our two agents a little bit more symmetric. And so we could do that by making the originator, A1, okay, do the same things that A2 does. Okay? So now agent 1 has to decide on a binary effort level. Okay? And if you don't exert any effort, then you also have the option of punting on the task completely. Okay? In other words, referring the task entirely to A2. Okay? Or if you exert some effort, then you can choose to go through the game just as we set up already. Okay? What this means, okay, is that there's now another threshold we call the theta 1 hat. Okay? And what we can easily show is that these referrals will happen whenever the originator's productivity is lower than that threshold. In other words, this is what the lowest types of originator will do. Okay? So just to give an intuition for what happens under these originator referrals. Okay? Under referral, what happens to A2's incentives? Well, now you no longer worry about whether you're going to win or not, right? Because A1 has taken herself out of the game. So the victory motivation now carries all the way through to the right side. Okay? And now what happens to A1's incentives? Well, A1 is only going to refer, only the lowest types of A1 will refer a case. So now we have, instead of 2 regions, 3 regions, referral, then autarky, then sharing. Okay, so it has to go in that order. Okay? And you can sort of see how a referral might actually benefit our world in this situation because, of course, only the weakest types of A1 will refer. When those types of A1s refer, then, of course, the A2s that receive the task are more likely to be stronger. Okay? And so this will result in a welfare gain. All right. Why don't I skip this and just talk a little bit about reward thresholds. One thing that we can imagine, even in this crude world where we don't have a principal who's writing a contract, is a performance standard. Okay? So what if beta is rewarded only if x1 plus x2 reaches a certain threshold value of t? Okay? So there are a few things that can happen here. Okay? First, this can improve A2's incentive to work. Right? This is just another hurdle to get over in order to receive the reward. It might improve A1's incentive to share if you place this t, okay, right near where an agent of type theta 1 was indifferent between sharing and not. Okay? Because now instead of getting the reward for sure by not sharing, right, she has to engage the other agent in order to receive beta. Okay? But if theta 1 is far below t, okay, then it might actually hurt A1's incentives. So the effect of sharing has to depend then on where t is placed relative to the threshold between sharing and not sharing for A1. Okay? And so we can visualize this in the complete information world with this. I mean, you know, think of t as being a budget constraint, okay? And for our agent 2, there are going to be all kinds of areas where the victory motivation again goes away, okay? Because she knows that there's no chance of actually receiving that. Okay? And so the trade-off then will be that we're always going to be losing. So we might be able to improve A1's sharing, inclination to share, but we're almost always getting rid of A2's incentive to work. Let me just wrap up with this final one. I won't say much about it. We were a little bit curious about the robustness of this idea that high types will share and high types will work. And so what we did was to think a little bit about a more general production function. Okay, so if we go to a CES utility function, so now the exponent here corresponds to whether we have synergies in production or not. Okay, and to do this, we had to go to an even simpler model. Okay, so there's no effort anymore. Okay, and now this is one where the productivity parameters are common knowledge, and the probability of victory will just be equal to the proportion of the productivity that you're bringing to the table. Okay, and what we get is the following. Okay, when rho is equal to 1, so that's linear production. Okay, Or when rho is less than 1, in other words, we have productive synergies, then we get what we had before, right? High types will share. Okay? Unfortunately, when there are no synergies, then we get the reverse. Okay? High types don't share. Okay? And so this is one thing that we're going to be interested in exploring. So, okay, how do we summarize this not quite complete paper? This is a common problem with, as far as we can tell, not much of a literature. Okay? And not really a lot of intuitions for what happens. Okay? So we've developed a framework with the 3 elements, right? Joint production, competition, and property rights, and try to build a model around that. The model that we have incorporates incomplete information and effort, but one question here is whether even these elements are necessary for describing the problem. Okay? Some of the results, or at least intuitions that we get, okay, there's this tension, strategic tension between inducing effort and winning. Okay? There is, at least under most of our specifications, this result that strong originators are likely to work, right? Strong originators are likely to share, strong partners are likely to work, okay? Rewards in terms of beta need to be intermediate, okay? We see all sorts of inefficiencies, in other words, all sorts of failures of collaboration, and one thing we hope to work toward is a better sense of what remedies there are for these kinds of situations. So that's all.
So could you go back to your earlier examples now and tell me however math goes into this, the SEC versus CFTC? I mean, what would I be looking for observables to sort of see which of these cases fits which?
So one thing I'd say is, so the result that I would most like to get, which I just don't have yet, is who should be the originator, right? So you have agents with different motivations and maybe cost parameters, and it would be great to sort of see, well, okay, given this configuration, who do we turn into A1, right? And I think that would be the thing I would want to know for that particular case. And I just don't know right now.
But that's a little, I find it a little bit unsatisfying because that's kind of like, trying to decide on a game who a first mover is in some sense. Right? It's not like, it's sort of arbitrary. It seems like in the model that's an arbitrary decision. You make one player A1.
Well, but there are laws about this, right? I mean, it's, in 2006, the mayor literally said, no, from now on, the New York Police Department will have primary responsibility over emergency management. And so they can let the fire department come and participate if they want or not. But that was a conscious decision to assign primary responsibility to one agent.
Yeah, okay, but then your story is, so then your story starts at that point, and then the question is whether the police department then allows fire department to play, or is there a prior game there that somehow the New York Police Department?
Well, so one way in which I would maybe read the past would be that whoever became originator was sort of very situation specific, right? It could be literally who got there first, okay, and who kind of set up shop at the scene, okay? And maybe this is in some ways a less efficient way of doing things than, if you understand this game and saying, well, no, A1 should be this guy, okay? Beyond that, I mean, I'd want to know what the result is, and that's.
So, still on financial services, and I'm thinking about this, and do a little bit of work on the implementation of certain aspects of the political climate, the implementation of certain aspects of Dodd-Frank, for example. So there, when they created the Consumer Finance Protection Agency, what they did is they basically took away the perk over that from everybody just about who previously had it, consolidated it, except for the FTC, which for some reason was allowed to keep a whole bunch of it. So I'm trying to think of, that's exactly what turf war plans for. So there, I'm still trying to think of your framework. What helps me in sorting that out? I think about was the FTC A1 you didn't want to share with this new agency, or what's going on? I'm still trying to sort of, I think back, there's a motivated story here about, if I think about it in terms of the war, who's protecting what turf there? Is that, would the FTC in that story would be A1 in this model, or is that the way to think of this? somehow they were successful in maintaining that position and therefore were able to then make this decision as opposed to let the Consumer Finance Protection Agency, which hasn't intended to create it. I'm just interested.
So one interpretation is, Congress is writing the law, and they're saying we want the FTC to be A1. Okay.
In this domain, but not the other agencies that were around. We're just going to eliminate them and give this new agency them A1. So,
right, and maybe maybe there's a story that's rooted in that can somehow be interpreted in terms of parameters here that would make that make sense. But we're completely silent though on whether A1 or A2 actually is appointed, right? I mean, we're just trying to characterize the properties, even of situations where the wrong originator is in charge. Yep.
On your examples were in public agencies, but it seems like within a firm, these problems crop up all the time. A firm is basically set up for joint production and develops, produces some output. In a bank that, decisions are made in the investment officer and the officer in charge of risk management, for example, has to decide portfolio and how to hedge. But just in mechanical production, there could be all sorts of issues. It seems like there must, people in organizational behavior, there must be a lot of studies of these kinds of things.
I feel like there should be, and I wish there were. Whatever it is that's out there just doesn't seem to be amenable to our, I mean, it's really easy to find examples like this, when you're talking about different government agencies screwing up, okay? It's relatively more difficult to find, private sector intra-organizational stories. And so on the one hand, I'm convinced that they exist. On the other, seems like either people haven't written about it in terms that are easy to translate into what we're doing, or, yeah.
But what is visually public here? Like, in some sense, you take it, you just change the name to...
You mean what's public sector?
Yeah, well, in one sense, it's like, so, because by that token, then they go stories in.
Yeah. Well, no, so, one argument would just be that, this is beta, right? So if this is a firm, we've got all sorts of contractual tools that we can use, and, the ability to provide incentives in the public sector because of civil service rules or whatever is just much more limited. Maybe this is an environment where people are competing on prestige, or these are fundamentally indivisible rewards that generate these kinds of incentive problems. And so I've convinced myself that there's at least one plausible reason for why we don't see as many of these in the private sector, but I would be very happy to to learn more about them. All right. Thank you.